Thank you very much. Okay, so today you've probably heard a little bit already about the goal that Lake Erie has for walleye in Lake Erie, so I won't reiterate that. But basically, we want to have a healthy walleye population throughout the lake that inhabits the West Basin, the Central Basin, and then the nearshore areas of the Eastern Basin. And so we have some objectives here: is protecting and restoring self-sustaining stream spawning stocks, maintain the nearshore habitats which support these high fisheries, walleye fisheries, and then so that we can provide sustainable harvest of walleye. Out of these comes some, in my opinion, some very straightforward research questions that need to be answered, or that should be answered, in order for us to make sure that we're managing this population in a sustainable fashion. So questions such as, where do these Western Basin stocks spawn? What habitat do they occupy when they're out in the open water? And then what are the population dynamics for these different stocks, and which can be used for the population model, or which should be used in the population model that Rich was just explaining. So we're hoping to be able to answer that with the new study we've overtaken. Well, I guess it's really not a new study, is it, anymore? It's about 5 years old. It just seems that way, I guess, to me. You've heard a little bit today about the Western Basin, the Central Basin, and the Eastern Basins. Just a brief summary would be: in the Western Basin, it's generally characterized as being warm and shallow, and it has a warm water fish community, basses, gizzard, shad, drum, things of that nature, with walleye inhabiting during certain life stages, but moving out as the summer warms up and as the temperatures get hotter. The Central Basin, which is moderate in depth, occasionally will stratify. This is where we'll see the anoxia set up in the Central Basin in the lower portions of the water column. And then the Eastern Basin, which stratifies pretty strongly. It's deep, it's cool, and supports cool and cold water fisheries. This is where our lake trout and our salmonids reside during the summer, as well as Eastern Basin stocks of walleye. And as a result of these different morphologies of the lake, you have different fish communities, right? And forage fish communities and habitats. So in the Western Basin, you have a lot of emerald shiners and gizzard shad. As you move to the Central Basin, you may see some more alewives, as well as emerald shiners and from smelt. And then in the Eastern Basin, where it's strongly stratified, you see the prominent offshore forage would, of course, be rainbow smelt. So the question is, how do walleye orient themselves and associate with these different habitats and forages? Well, Mark Kirshner, a few years ago, I guess more than a few years ago, came out with this paper as modeling the sources of variation for growth and predatory demand of Lake Erie walleye. And he talks in there about the Western Basin stocks. As the individual fish get older, their physiology changes, and they have to, in essence, move to the Central and Eastern Basins in order to conserve energy. So he did a nice job of explaining that. And a lot of the inferences he drew was from some tagging studies that were done, and I'll explain those in a minute. And what we're kind of looking to do with this new telemetry stuff is expand on that, have a better understanding of why these fish are moving, when they're moving, and so on and so forth. I referenced earlier tagging studies. This was, I think, if I'm correct, Bob Haas's brainchild back in the late 1980s, where they started jaw tagging walleye, releasing them in the Western Basin, and then they would look at returns through time. Well, the tagging project went from 1990 to about 2007. During this time period, approximately 117,000 walleye were jaw tagged, and resulting in about 9,000 recaptures. So there's quite a bit of information that was learned initially from the movement of walleye in Lake Erie. Here we have the Eastern Basin returns. These are fish that were tagged in the Eastern Basin and then subsequently harvested by anglers. And you see the predominance of recaptures for these Eastern Basin fish centered around the Eastern Basin. Not much straying out of the Eastern Basin. However, but if you take a look at the Western Basin stocks, they move a lot. And so they would move northward up towards Lake Huron, as well as out towards the Eastern and Central Basins. And this work was summarized by researchers back in 2007, and it gave us a little bit further insight into how these stocks are moving and orienting themselves. Some of the findings of their project or their paper were that the Western Basin stocks were highly mobile, and the larger, older females were more likely to migrate. And this migration was directed northward and eastward. Well, while this was very groundbreaking at the time, the information that we were getting back was very limited because it was a point A, point B type of study. So you only knew where you released the fish, and then you only knew where you recaptured the fish. And if the fish was at liberty for 10 years or for 5 years or 3 years, you had very little information of what the fish was doing between those two time periods. So in comes Glados, the Great Lakes Acoustic Telemetry Observing System. We like to refer to it as the Greek god of telemetry studies on Lake Erie. And the point of this project was to address these movement and behavior studies at geographic scales that were previously just not possible because we didn't have the technology. So the way this telemetry equipment works is there's an acoustic receiver. It's located at the bottom of the lake. It's about the size of 2 soda cans stacked end to end, and it just sits there and listens for fish. As a fish moves into the sphere of which the receiver is able to listen to, the information from that fish, the time that it's there, and then its transmitter ID is coded. Well, this acoustic telemetry network has really taken off and spread quite prolifically in the Great Lakes Basin, specifically in Lake Huron and recently in Lake Erie. And so each of these little dots, in essence, represents like a toll booth. As a fish swims by it, the receiver there receives information and stores that data until we're able to come back and download the data. So on Lake Erie, we've had a series of projects. We've had one in the Maumee River, one in the Toussaint Reef, one in the Sandusky, and now we have 2 projects coming online this year, one down in Van Buren Bay, and then the other one in the Grand River, Ontario. And so as you can see, over the last 5 years, we're going to have quite a few telemetry fish out there swimming around, giving us an idea of what they're doing. A lot of these project objectives vary, but overall you can lump them into a few broad categories. One is looking at spawning site fidelity rates. If a fish spawns in the Maumee River, how likely is he to go, or she, to go spawn somewhere else in successive years? Inter and intra-lake movements. What fraction of this cohort goes up to the north or out to the east? Whoops. Habitat selection. Where are these fish going, at what time of the year, and potentially why? Temporal structuring. How does this vary through the course of the year? And then we're able to also, using with the help of Lisa Peterson, taking some of this data and then estimating mortality rates, fishing and natural mortality rates, because these are in essence known fate models. We know what's happened to this fish. As long as we've done our due diligence by putting receivers out in areas where we're going to intersect these fish, we should have an idea of what these fish are doing. And so we can get at fishing and natural mortality rates at a different way than we've done it historically. So if we take a look at Lake Erie specifically, we see this vast network of different receivers. And so I'm going to focus here on Toussaint Reef. Toussaint Reef is a Western Basin reef. It's probably one of our larger reefs in the Western Basin. And what we've done here is we put a series of receivers out on the reef itself. And the way this works is as you put those receivers out there and fish swim by, you're able to estimate where that fish was in this array. And so up here, the little schematic, what you can see is all the little black things are all the little receivers. And as a fish swims on this reef and multiple receivers are gathering the information sent off by the tag, they use the black box, VEMCO we call it. They run the data through there and it triangulates its position. So we get a latitude and a longitude. Every time that tag goes off, we are able to say, with some degree of certainty, this is where the fish was. And so on this graph, this figure right here, what you see is actually the lat and long, or the position of this individual fish on Toussaint Reef during this period. And I'll show you some more animations like this in a few minutes. Because I was afraid I was going to run out of time, I had 2 animations that I deleted. So this is for a female that we observed on Toussaint Reef in 2004. There's another male that I pulled out as an example, and it literally looked like somebody just painted this reef. You can't see any of the contours because this male was just on the reef for about 7 days straight, just back and forth all over it. So it's giving us an idea of where on this reef this fish may be spawning. The other arrays that we have out is we have the Western Basin cordoned off. And so this is more broad scale movements and allows us to get an idea of when fish are moving through a general area. So what I have here is just the number of unique fish detected on that Western Basin array through time. And so what you see is in the fall, you start seeing males show up on the Western Basin array, somewhere around September. Fairly constant number of fish in this area all the way through February, you see the fish aren't there anymore. Most likely they have moved over to the reef. They're now spawning on the reef. And then you see the males coming back later in April into May. So you see these fish making that east to west migration and then back. And if we overlay that with the female, just females, you kind of see the same thing. It's skewed a little bit. So what you see here is a buildup of females through time. Then all of a sudden you see this peak at the western basin. So we don't know if these are actually just fish kind of hanging off in the kind of on the perimeter of the western basin, running in, doing what they need to do, and then coming back. What I'll show you on these animations, the females are on the reefs for a very short period of time. So in addition to just finding out where these fish are in the lake, we're able to use these transmitters actually to find out what depth of the water they're occupying. So as a fish swims into the area that the receiver is capable of listening in, it transmits on some of the transmitter tags we have out there the depth at what the fish is occurring at that site. Okay, so the fish comes in, this fish is coming in here at looks like at noon. Then we detect it again at 1 o'clock. We've seen it's dropped down in the water column. So the receiver is actually able to tell us where that fish was in the water column at that period of time when it was near that receiver. So this graph kind of summarizes the data we've collected to date of the fish that had this depth transmitter associated with the regular transmitter. And so what you see here is in July here, the fish are oriented towards the bottom. We weren't detecting any of these fish, during the winter. And then I believe this is for only central basin fish anyway. So these are the receivers that were out in the central basin. And then as the summer progresses, you see the fish moving deeper and deeper to deeper habitats, and they're staying near the bottom. And so this is kind of interesting, if you ever fish, at least as a recreational fisherman for walleye in Lake Erie, you always think, oh, they're up high and suspended. Well, based on the information we got back from these tags, it looks like they actually spend very little time up in that in that area of the water column. So this, as a biologist, can tell me, maybe we need to reevaluate how we're sampling the population if they're really not up susceptible to our survey gears that we fish in the fall. Now we can also do something a little bit even cooler, I guess, in my opinion, is we can take our regular receiver data, we can put a different type of transmitter in this fish. It's actually a sensor which captures the depth and the temperature simultaneously. So here we have a male who was released on April 30th in the Maumee River. These dots represent where this fish was spotted throughout the course of the summer. Then it was harvested up here in Ontario in July of 2014. And so if we take the data here I'm showing in this little this inset right here is actually the depth data. So where that fish was, every 4 hours it records the depth of where that fish was. So every 4 hours I have an idea of where that fish was. So now if I take the depth data I'm getting from that small tag and marry that with the acoustic telemetry, the acoustic transmitter data, where that fish was in the lake, these open circles represent observations where I know exactly where that fish was within that receiver through time. So here we see this fish in the Maumee River. It looks like it crossed the western basin, going over here up into Ontario. Here it looks like it's migrating because these dots right here correspond to when the fish was right here. It was migrating near the surface out into the central basin. And then we saw the fish again later on in the summer off of Cleveland and out in the abyss. And we have an idea, we see this fish using deeper and deeper habitats. So really, we're getting a complete history of where this fish was during the course of these 4 months, right? And so we can do the same thing with the temperature. We can look at what temperature this fish was occupying at those same periods of time. Again, this graph shows the open, or right now they're black because there's so many on top of one another, where we know where this fish was at a specific point in time. And we'll say, oh, look at this in the summer when it was on the central basin. Look at the variety of temperatures it was utilizing. Near 25 and then on some days down near 11 degrees Celsius. Very wide temperature fluctuations within a 24-hour period for this individual fish. And then if we want to be even more particular or more precise, we can look into the diurnal use. Where was this fish during the day? Where was this fish during the night? And what we kind of see here, I believe, on this one fish is that during the day it comes up near the surface, and then at night it goes back down. That's completely not what walleye are supposed to do, right? They're supposed to come to the surface at night and go down at the day. Well, this information here is giving us a new insight into the behavior of fish walleye during the course of the day. So here we'll get to the fun thing now. This is some animations, and was a female that was released on the 5th. This is wrong. This was actually released on the 5th of April in 2013. So I'm going to take you through the whole time that we have information for this one fish. All right, Nick, so could you press play? So this is the fish getting released near, this is where Two St. Reef is. This is Crib, Niagara. This is that female being released out into the lake. We had a bunch of VPS receivers there, so we could see that fish being released, literally kicked off the boat and letting to swim away. She disappears for a few hours. Then around, what was it? I think it's about towards 5 o'clock, yep. We see the fish swim back through the ray, so a couple hours later, and then there she goes off to the northeast. Okay. So, yes, so here, all right, Nick, play this. So here, now watch the dot. Here we have the fish migrating. You see it moving now towards the end of the summer. It's detected on the receivers over by Fairport Harbor. Towards the fall, starts making its way back, and now it froze.
Showing it that's the end.
Showing that that's the end. All right, advance it. Technology. Horrible. All right. So basically that fish migrated back to Two St. Reef the following spring. So here's that fish, that same fish, in April of 2014. All right, Nick, let's try this one. All right, here she comes onto the reef. She's kind of swimming around the perimeters. Maybe there were too many males on there for her liking. I don't know. She swims back off. And here we see her approach again, spends some time there, and then slowly drifts back off. All right. So if we take a look at this information of the number of observations for this individual fish through time, what we see is this fish come in late at night, around midnight, spend a couple hours on the reef, exit the reef to never be seen again. All right, Nick? Let's try this one. All right, so here we are in 2014. It was on the reefs, and now we see the fish in the summer of 2014. Now she went up to the North Shore, cutting across the lake, heading back west. So the last time we saw this fish was actually off of Fairport Harbor on the 11th of October. Well, this one was caught. We got this fish back just a few weeks ago, actually caught by ice fishermen off of West Sister Island. So we were able to take the information from this fish and just basically reconstruct what it did over the last 2 years, in essence, after it being recaptured. Okay, well, so what? That's nice. They make nice animations when they work, but what's this information useful for? Well, currently, walleye habitat is defined as the shallow, turbid waters of Lake Erie. And this is within the 13-meter contour in the west and central basins. And so this is a criteria that's actually existed for quite a few years, right? Well, we're able to evaluate that. In a recent publication by Panda et al., they commented about this. They said the current depth-based definition of preferred habitat may not be an adequate representation of walleye suitable habitat. So using this type of technology, we can actually start evaluating this. We can start saying, where was this fish? How long was it there for? Does this vary for different stocks? Does it vary for different aged fish, different sexes? And we can start evaluating this and perhaps define some new criteria or some more updated criteria than what has historically been used. So what have we learned since 2008? This kind of covers the last time of our State of the Lake reporting was. Well, some of the movement patterns for walleye, I would argue, have been confirmed. We do see this eastward progression as the summer goes on. Some new patterns are emerging. I guess it was a surprise to me to see these fish just going cross basin. I only gave you one example here, but there are a lot of other fish that we're seeing these things on the North Shore, on the South Shore, on the North Shore, on the South Shore, heading to the west. You think they're going there, then going back east for a couple months, and then heading back west. So I think some new patterns are emerging. I think what we're starting to learn is it's a lot more complex than we originally had thought. We're starting to get a new understanding about temperature and depth and how fish and walleye and Lake Erie relate to these two variables. I think the fact that walleye are down in the low teens during the middle of the summer has kind of caught me off guard. That's not the preferred walleye temperatures that we've all read about in the literatures. Well, what are these implications for management? Well, they're giving us a better idea, I would argue, in the spawning ecology of these fish. How long are males and females on the spawning grounds? Things of that nature, things that we don't have any other way of knowing other than to actually follow these fish. Stock-specific movement rates, the timing of these movements, as well as developing population parameters. One of the biggest challenges, though, I see to this is how do you take the information from an individual and extrapolate that up towards the population? And so I think that's what we're going to be wrestling with here, and probably for the next 10 years or so, and how you take all this data and make inferences about the population as a whole. Well, I see the red light has come on, so I've expired my time, but I do want to thank the Great Lakes Fishery Commission for helping all of the agencies pull this project off. A lot of us have constraints in the way we're able to purchase things, and we thank the Commission for administrating some of these projects and for distributing the reward dollars, because otherwise it would be very difficult for us to pull off such a project.